Okay, Shabaz. For those who don't know, he is an ex-part of the Bradco team who left, but we can't get rid of him, so he's come back to give us a talk this evening on some Azure Stack HCI. So over to you.
There's actually a story behind why I left. Basically, me and Imran couldn't agree. We had a fallout over how is it GIF or is it GIF? And we had a massive fallout, and we've still not really made up about it. But
not over glove jam and ice cream.
No, that was Simon. Okay, so can you guys see my screen?
Yep.
Excellent. Okay. So those are my socials, but I'll put them in the chat later on. So welcome to my presentation. Bit of a bio around me before I move on to what we're going to talk about today. So my name is Shabaz Darr. I'm an infrastructure master. It's just a job title which I didn't choose, but I do love it. I'm a Microsoft MVP, Microsoft certified trainer, published author, and a content creator. So I do have my own YouTube channel where I do a lot of content around different Microsoft exams, but also I'm actually doing a series at the moment around this exact topic, which I'm going to talk about today. So today's session, I'm going to focus. It's a deep dive into Azure Stack and a little bit of a session agenda. So to talk a little bit, introduce Azure Stack as a topic, but then the main area of my focus is going to be around Azure Stack HCI, and the reason my interest was piqued around Azure Stack HCI was because as of a month or two ago, Azure Stack HCI with Azure Virtual Desktop integration went GA, and that's kind of been my background. Azure Virtual Desktop, that's kind of what I specialized in when it first kind of dropped, or when it was Windows Virtual Desktop, just kind of at the start of COVID. So yeah, this topic around Azure Stack has really piqued my interest, specifically HCI. So we'll do a bit of an introduction into Azure Stack. I'll talk about the HCI technologies, talk a little bit about deploying it, and then talk about how we can integrate it with things like Azure Arc and AVD as well. And I've got a little live demo, which I'm going to do at the end, where I actually I'm going to deploy it, a virtual sandbox of it within my environment. So yeah, we'll do that right at the end. Let's talk about a little bit about what is Azure Stack HCI. So it's a family of products essentially, and it provides an extension of sort of Azure. And it allows businesses to consistently build and run sort of hybrid applications and workloads across data centers, edge locations, remote offices, and the cloud. And the Azure Stack family really consists of three main areas, which is Azure Stack Hub, Azure Stack HCI, which I said is going to be the main focus of my talk, but also Azure Stack Edge. It also allows you to have an efficient use of cloud technologies, which sort of aren't just limited to migration scenarios. And it also sort of plays a significant role in the sort of hybrid environments, with some computing resources remaining on premises, so you can essentially bring that cloud to your data center. Azure Stack products share some characteristics. So obviously there's three different sort of products, as I mentioned, but they do share some characteristics that facilitate transition to the hybrid cloud model. And they sort of include, on-premises deployments, close integration with Azure, sort of modern technologies that kind of accelerate the replacement and consolidation of your legacy infrastructure. That sort of pay-as-you-go pricing as well, which kind of makes cloud so appealing for people, that consumption model, using those sort of same subscriptions and that monetary commitments and billings you would have in Azure. But also purpose-built and pre-configured Microsoft-certified hardware, which you can get from Microsoft or sort of third parties as well. I think Dell do it as well. So before I get into sort of the detail and depth of Azure Stack HCI, I do want to touch on the other sort of versions of Azure Stack, or the other family members, let's call them. So Azure Stack Hub, this allows you to deploy a subset of IaaS and PaaS services that are available in the Azure public cloud, but in your own data center or your own premises location. These services can include VMs, app service, web apps, API apps, function apps, but also sort of SQL and MySQL databases, containerization, event hubs, Key Vault, IoT hubs, and that sort of service fabric clusters as well. And more recently, Kubernetes clusters as well. From a hardware standpoint, so each Azure Stack Hub instance is sort of an integrated system, and it consists of pre-built racks of between 4 and 16 physical servers. Each system then has its own sort of well-defined interface, and that exposes the functionality required to manage its sort of operations and implement those workloads. One thing to remember is, though, these interfaces don't provide direct access to the OS running on the physical servers, so you can't actually access that. That's kind of out of bounds, which is different to the other sort of family of Azure Stack. You can interact with the interfaces by using sort of management and programming tools equivalent to the ones in Azure. So, talking about web-based portal, Azure PowerShell, CLI scripting tools and stuff like that, SDKs. So this diagram here is a bit of a dictate from Microsoft, if I'm honest with you, Microsoft Learn. So this gives you a bit of an outline as to what Azure Stack Hub is. So as you can see, you've got that top layer, which is all your services, your VMs, your scale sets, your databases, etc. And then you've got that Azure Stack infrastructure, which includes your IaaS and your PaaS services, and the underlying hardware. Then you've got with your sort of switches and your connectivity below that as well. And on the outside of that, you've got your users, your managed service providers, which can integrate with it, your operators. Again, and you'll notice as I go through the presentation, when I show the Azure Stack Edge and Azure Stack HCI, the differences in the sort of deployments. What Azure Stack allows you to benefit from is sort of the latest advancements as well in cloud-based containerization and those sort of microservices. But in like an offline version, basically. So with Azure Stack Hub, you don't connect, even though it's got all those cloud services. It's not actually connected to the cloud. It's kind of an offline version of your Azure services. So just want to clear some things up around what exactly what Azure Stack Hub isn't, because it's important to understand what it is, but also it helps to understand what it quite isn't, because there's obviously Azure Stack HCI and Edge. Where are those boundaries and what can't this really do? It's not a replacement for your virtualization technology. So it's not designed to replace an existing on-premises private cloud, like your VMware stack or your Hyper-V stack, for example. It's designed to introduce that public cloud operating model in your data center. It's not customizable infrastructure either. Azure Stack Hub relies on pre-configured sort of systems, as I mentioned before. And they're constant and they're like in a known state with support for sort of customizing hardware. It's not a solution that eliminates the need for infrastructure updates either. Azure Stack Hub does require that you keep it up to date and keep that infrastructure components up to date as well, and do that regularly. However, you can perform the updates without having to take offline, any of your workloads running on that infrastructure, which is always very helpful. Finally, it's not a solution that eliminates the responsibility of underlying infrastructure. Microsoft host and manage that Azure cloud physical and virtual infrastructure. But with Azure Stack Hub, you're going to rely on the availability of your infrastructure within your business and within your offices or data centers. So it's your responsibility. So if you remember the responsibility model that Microsoft have with IaaS, PaaS, and SaaS, this is very much kind of clearly all you as a business, you as a consumer, your responsibility. A couple of common use cases. So we're talking about latency and bandwidth sensitive workloads. It can help you address those. Disconnected workloads as well, as I mentioned, you have it in an offline state. So you can introduce cloud capabilities, such as like on factory floors, cruise ships. I mean, in sort of industry areas I've worked in and SAD, I know the industries you work with as well. We're talking government entities with certain classifications like secret and stuff like that. It's got a use case there as well, because they can't really have any connectivity with the outside world. Something like Azure Stack Hub might be able to meet that criteria. Also, workloads that are subject to residency requirements, so similar to what I just said there, really. Where and also auditing, financial reporting, foreign exchange, that sort of stuff. So let's talk a little bit about Azure Stack Edge and what that is. So this is going to allow you to perform processing and sort of machine learning based workloads on your on-premises locations, and upload it to Azure by using sort of the purpose-built Microsoft provided appliances residing on your on-premises location. So it supports sort of generic virtualized and containerized workloads, but it's optimized for sort of processing and analyzing data at the edge. and then transferring those results into the cloud. So this is not like this does have connectivity with Azure, and it integrates with Azure Cloud, unlike Azure Stack Hub. It also focuses on processing and analyzing and transferring that data, and it provides sort of specialized capabilities because it offers, those include sort of graphical processing units, so GPU based, or even field programmable. Try saying that fast. Programmable gate array, so FPGA based workloads, along with sort of vision processing, so VPU, and so very specialized workloads. So we can probably see a difference between this diagram and the Azure Stack Hub one, because again, we have that integration with Azure Cloud here, where we didn't have that with the Hub. So again, on the right-hand side, we have our Azure Cloud, includes stuff like, the integration with IoT Hub, Azure services as well, and your sort of storage. In the center, that's where we have our Azure Stack Edge, which is again in our data center somewhere on premises location. So you've got the Kubernetes and all those sort of services, those containerization services, with that local storage. You can also integrate with your own premises systems and data. But then on the left-hand side, we have all our sort of devices, our IoT devices, which are filtering in information into that Azure Stack Edge. So yeah, again, very different from what we saw in the Azure Stack Hub diagram. So these are some common use cases for Azure Stack Edge. Data processing, you can use it to transform data and optimize it, and to then streamline that transfer analytics into Azure Cloud. Using and working with Azure machine learning models, again, a lot of data transfer involved with that. So again, it can speed that up and improve that performance transfer. And then you can use it to facilitate continuous transfers of on-premises data to Azure storage for longer term retentions as well, for sort of process and analytics. And now we get to my favorite out of the three, if I'm honest, again, just because it integrates with AVD. That's literally the only reason. So Azure Stack HCI. So unlike Hub, but it's very similar to Hub, which allows only a restricted set of administrative tasks, sort of via well-defined and constrained interfaces. HCI gives you full direct access to its underlying hardware and that OS running on the sort of cluster node. You can manage your Stack HCI operations the same way you would any Windows server-based cluster using, PowerShell, Server Manager. You can also optimize that experience as well. You can use Windows Admin Center to do that. Azure Stack HCI also offers sort of DR capabilities that's built on its sort of support for stretch clustering. So by deploying that stretch clustering, and I think I do talk about that later on as well. You can synchronously replicate its workloads across two separate on-premises locations, and then that can automatically fail over between the two. And on the other hand as well, Azure Stack HCI, it doesn't support implementations of Azure-based deployment methodologies that rely on Azure Resource Manager, though, which is available on Azure Stack Hub. And also it can't inherently enforce or provide multi-tenancy either. So again, this is very similar to the Hub diagram. But again, the difference is you can have that better integration with Azure, and also you can manage it, whereas you can't really manage the hardware or the OS when it comes to Azure Stack Hub. So again, start at the bottom, we've got that sort of validated partner hardware. So again, I mentioned Dell earlier. I know Dell do sort of validated partner hardware you can get from Microsoft. Again, that Azure Stack HCI OS, which I'm going to go into more details, the Hyper-V, Storage Space Direct, and software-defined networking. I will talk about those in a bit more detail shortly. And then we have our sort of operating system VM, so Windows Server on your Hyper-V, Linux, and AKS. And then as we go further up, we have that admin center to kind of make that experience better, and then we can connect them all into Azure services, which you can't do on Hub. So again, just some common use cases, branch office and sort of edge workloads, VDI workloads, which is again AVD, which kind of spoke about already. We will talk about that in more detail shortly. SQL Server, high performance SQL Server workloads, you sort of trusted enterprise virtualization as well, scale out storage, AKS, the containerization clusters as well. And one of the big ones is sort of your DR, the virtualized workloads, being able to put it across different locations and synchronize those. So yeah, very, very good use case. So I just want to quickly, obviously I've spoken about the three, but let's kind of compare them now. So with Azure Stack Hub, as I mentioned, you run it on your own private autonomous cloud native. You can run your own autonomous cloud native applications in the cloud, connected or disconnected to your on-premises environment. The main use case is disconnected. That's kind of where people tend to use it over Azure Stack HCI. With ACI, Azure Stack HCI, this is a consolidate and modernize your virtualized workloads by using that sort of on-premises hyper-converged infrastructure, and then you integrate that with Azure. And finally, with Edge, this is to get sort of immediate insights into your on-premises data with sort of an Azure-managed Edge compute appliance by using hardware-accelerated machine learning. And again, there's a bit of a table where just comparison about the number of nodes required, the hardware, sort of the scenarios. So as you can see, Azure Stack Hub supports that disconnected scenario, that offline scenario, which I've mentioned. Though, does it provide Azure consistent IaaS and PaaS? Azure Stack Hub does, but HCI and Edge don't. Branch office scenarios, again, Hub doesn't, but then with HCI and Stack Edge, you can have that. And I think I mentioned the use case of trusted enterprise virtualization, which is available for Azure Stack HCI only. And finally, does it have built-in DR? Azure Stack Hub does, but Azure Stack HCI and Azure Stack Edge don't. You can have that with Azure Stack HCI, but it doesn't have it built in. Sorry, just to continue on that topic. Some more characteristics and differences here with your HA for virtualization, virtual machine, sorry, pre-configured private cloud, the support of Kubernetes across the board, all three support AKS. And then again, just again, more characteristics and just showing you the differences between the three, really. I'll try and share my slide deck after with Saj and the team so they can make it available. I'm also doing a series on it, to be fair, so you can check my YouTube out as well. So let's just do a bit of an intro into Azure Stack HCI technologies now. So one of them mentioned already around Hyper-V. So Hyper-V is and I'm sure we've all been around IT for a while. Hyper-V is a very very well-known technology, Microsoft's sort of virtualization technology for on-premises. I'm sure most of us probably have used it at one point in our career. But essentially, Hyper-V is a Microsoft implementation of a hypervisor, and it applies resources of a sort of single host computer and distributes them across multiple VMs running on sort of the same physical hardware. And then you can install a Hyper-V server role, and that implements a software layer known as a hypervisor, and that can control access to the host physical hardware. And this is just like a diagram of how that, again, looks. Again, quite a common diagram. I'm sure you guys have seen this before, where you've kind of got the hardware layer at the bottom that has that CPU and that virtualization extensions going into your hypervisor. And then that's where you start sort of the virtualization. So you got your vCPU going to your Gust OS, and then your root OS as well on the left-hand side. So talk a little bit about nested virtualization, because that's quite a big part of Azure Stack HCI. Excuse me. So nested virtualization is a Hyper-V feature, and it allows you to install and run Hyper-V inside a guest VM. So it's almost like Hyper-V within Hyper-V. It enables a guest VM to host a Hyper-V host, and then you can host other guest VMs. It can be useful for implementing virtual tests and deployment environments, and that otherwise you'd need hardware for. So it kind of can save you a bit of cost. And you can use it for different sort of test and dev environments, as I mentioned. Sorry, just clear my throat 1 second. Mute myself while I do that. Apologies. Okay, so this diagram, again, it builds on top of the Hyper-V image that you saw earlier, but we've got that additional layer of the nested. So again, we've got that hardware virtualization at the bottom, which we have with our physical CPUs, and we then have those virtual extensions going into the hypervisor. But then we have two layers of almost the virtual CPU. So we have the Windows root OS on your sort of your main Hyper-V physical host. But then you have another hypervisor with a vCPU that goes into your next set of Windows root OS and guest OS, which is that level 2 at the top. So just we'll talk a little bit about the features of Hyper-V. So new releases of Windows Server and updates always add features to Hyper-V for supporting different workloads, and these can increase performance and enhance your security. One of them is sort of the sort of management and connectivity, so you can manage Hyper-V environments with Windows Admin Center, Hyper-V Manager, or Hyper-V Module for Windows PowerShell and sort of virtual machine connections. We've also got a good feature with portability, so you can make it easy to move and distribute VMs. Hyper-V can provide features such as migration, storage migration, and standard import-export functionality. You've got the DR and backup feature, so it can support Hyper-V Replica, and that creates copies of VMs in your physical locations. We've also got security features, so Hyper-V supports security features such as secure boot and shielded VMs. And optimization, so for all the supported guest operating systems, Hyper-V includes a set of sort of customized services and drivers. These are called integration services. And these integration services include sort of time synchronization, OS shutdown, data exchange, heartbeat and backup and stuff like that. So again, this is another feature of Azure Stack HCI. So also I'm talking about, sorry, these are all features of Azure Stack HCI, just to confirm if I'd not mentioned that. So failover clustering. So this is a Windows Server and Azure Stack HCI feature that provides high availability for your common workloads. For Azure Stack HCI, the cluster would only include virtual machines. You create a failover cluster by enabling storage spaces direct, which we are going to talk about shortly, on multiple servers running Azure Stack HCI. If a server that is part of that HCI cluster fails or becomes unavailable, another server in that same failover cluster will take over that task. This process is called failover, and it results in minimal or in certain cases, no service disruptions at all. So just want to talk about a bit about components of Azure Stack HCI. So we spoke about a little bit about features. Let's talk about components now. So first of all, we've got nodes. So nodes are Azure Stack HCI computers essentially, and they're members of that failover cluster and enabled with for storage spaces direct. These computers have a sort of failover clustering feature that we just talked about installed on them, and they can run highly available VM workloads consisting of services, applications, and resources. We then got clients. So clients are computers that consume available services and applications running within that highly available virtual machine. There should be multiple network paths between clients and clusters as well. Which brings us on to networks. So networks enable communications between the nodes and computers consuming clustered workloads. Again, talk about clustered VM role. So clustered virtual machine role is a highly available role, and this runs on the nodes. Clients consume this service by connecting to that virtual machine. If such a virtual machine becomes unavailable on that node, the failover cluster will then fail over automatically to another node. We then have resources. So resources are physical or logical elements such as a storage pool, a virtual disk, or sort of virtual machine, which the failover cluster can manage. And finally, we've got the cluster storage. So in addition to its own local storage, where Azure Stack HCI OS is installed, each cluster node has local storage as well. This makes up that shared storage pool. So again, this diagram shows you all those sort of features and all those components combined. So you can see the network connects Azure Stack HCI with its clients. We've then got the sort of dedicated network between the nodes as well. So as I mentioned, multiple connectivity, multiple network connectivities between the nodes. We then have that local storage and clustered storage with our virtual machines at the bottom. So these are all the sort of components I just mentioned in a diagrammatical form. So let's talk a little bit about Windows Server software defined storage. So this is one of the foundational building blocks of Azure Stack HCI. However, unlike Hyper-V and failover clustering, software-defined storage isn't an individual server role or a feature. Instead, it actually consists of different technologies that frequently complement each other. So you can combine these technologies to implement various virtualization scenarios, such as guest clustering or HCI. And these technologies include storage spaces, cluster shared volumes or CSVs, server message block or SMB, SMB multi-channel, and sort of SMB direct. So to use Azure Stack HCI in your proof of concept environment, you're going to rely on most of these technologies. One of the primary benefits of this approach is that it simplifies the provisioning and accessing of the storage resources. So again, just to go through some of those features I mentioned. So storage spaces is a storage virtualization capability that Microsoft has built into Azure Stack HCI, Windows Server and Windows 10. The storage spaces feature consists of two components: storage pools, which are a collection of physical disk aggregated into logical disk that can manage a single entity. The storage pool can contain physical disks of any type or size. It then consists of storage spaces, and these are virtual disks that you can create from sort of free space in your storage pool. The virtual disks are equivalent to LUNs or a SAN in all sort of on-premises lingo. So we mentioned CSVs as well earlier, so clustered shared volumes. So this is a clustered file system, and it enables multiple nodes of a failover cluster to simultaneously read from and write to the same set of storage volumes. So the CSV volume is mapped to subdirectories within that sort of C cluster storage / directory on each of your cluster nodes. The mapping allows cluster nodes to access the same content through the same file system path. While each node can independently read from and write to individual files on a given volume, a single cluster node serves as sort of a special role within that CSV owner or coordinator of that volume. You do have the option of assigning an individual volume to a specific owner. However, a failover cluster automatically distributes CSV ownership between cluster nodes. And this diagram again does kind of show that in use. So again, you've got that C cluster storage volume. You like kind of link at the top. So you've got 3 volumes. You've then actually got the logical volumes underneath that, and then you've got the storage pool below that as well. So I just want to, again, just touch on server message block SMB3, which again I mentioned earlier as part of that software-defined topic. So the SMB protocol is a network file share protocol. It provides access to files over traditional Ethernet networking via TCP protocol. It also serves as one of the core components of software-defined storage technologies, as we mentioned. And Microsoft introduced version 3.0 in Windows Server 2012 and has been incrementally improving it in subsequent releases. But again, big foundational component of here is Azure Stack HCI storage spaces direct, and this represents the evolution of storage spaces. It applies storage spaces, failover clustering, CSVs, and SMB3.x to implement virtualized, highly available cluster storage by using local disks on each storage spaces direct cluster node. And it's suitable for hosting highly available workloads, and those include VMs and SQL Server databases. Storage spaces direct eliminates the need of attaching storage devices to multiple cluster nodes in a failover clustering scenario. And you guessed it, I have an image that kind of shows that in use. So again, at the bottom layer here, we have our storage pools. So these are sort of local hard disks and solid state drives. That then has that sort of software storage bus attached to it, which then filters into our cluster. So our physical Ethernet connectivity between the servers, and they can see the storage spaces with the CSVs and that cluster storage volume, and all our multiple VMs at that top layer there, connecting into all that and using all that shared storage. So just want to talk a bit about workload models. So there are 2 deployment models of Hyper-V workloads. You use these storage spaces direct. We've got disaggregate, or disaggregated, should I say. And in the disaggregated model, the Hyper-V hosts, in this case the compute, are in a separate cluster from the storage spaces direct hosts, which is our storage. And you configure Hyper-V VMs to store their files in the storage cluster by relying on SOFS, allowing you to scale the Hyper-V cluster and the software-defined base cluster storage independently. We've then got hyper-converged, and in the hyper-converged model, the cluster nodes operate as both Hyper-V hosts and storage spaces direct hosts. And this deployment model has compute and storage co-located on the same set of cluster nodes. And to scale up the cluster, you just need to increase the number of its nodes. So we've talked about software-defined storage. Again, another key pillar of Azure Stack HCI is software-defined networking. So let's move on to talking about that. So I'll refer to it as SDN, because I can't bother saying software-defined networking all the time. So SDN provides a method to centrally configure and manage physical and virtual network devices. And these devices can include routers, switches, and gateways in your data center. Network abstraction, and this is the virtualizing the network, which allows you to abstract your applications and workloads from the underlying physical network. Similar to server virtualization with Hyper-V, network abstraction provides a uniform interface for provisioning and managing physical network devices such as switches and load balancers. Finally, network management, the ability to efficiently manage virtualized network infrastructure, in sort of is highly dependent on the tools that facilitate configuring virtual network objects and policies. PowerShell offers the most versatility. However, Windows Admin Center and the sort of Microsoft System Center Virtual Machine Manager also simplify the complexity that is inherent to sort of scripting-based management. So talk about some primary components within SDN. So Hyper-V Network Virtualization, or HNV. This isolates network traffic between different workloads running on that same physical infrastructure. So the isolation relies on encapsulation protocols such as virtual extensible LAN or VXLAN, or network virtualization generic routing encapsulation. This allows the creation of sort of overlay networks with potentially overlapping IP address ranges and required for sort of multi-tenant scenarios. We then have Hyper-V Virtual Switch. This is going back to Hyper-V days for those people who have experience with that. And this is a software-based layer 2 Ethernet network switch, and you can use it. You can use this switch to connect guest VMs and their Hyper-V host and physical networks as well. Then got a component called set. So this enables you to combine up to 8 identical physical network adapters directly into your Hyper-V virtual switch. It provides load balancing and bandwidth aggregation functionality, resulting in high network throughput and for your virtualization workloads. Finally, a primary component is a network controller. So this is a Windows Server and Azure Stack HCI role. It serves as the centralized and programmable point of automation for sort of virtual and physical network infrastructures in your Windows Server-based network, or SDN. And it manages deployment and configuration of your network services, including support for provisioning virtual appliances that deliver that same functionality as your hardware-based network devices. I'm good for time, yeah. Move on to planning and deploying Azure Stack HCI now. So we are getting closer to my little demo that I want to do. So I just want to talk about some Azure Stack HCI workloads. So these are some of the typical workloads that you'll find with Azure Stack HCI. So it allows you to deploy Windows and Linux-based virtualize and containerize workloads on your hyperconverged infrastructure. Cluster in your own data center, and these are managed by a service provider. From a hardware standpoint, each Azure Stack HCI cluster consists of between 2 and 6 validated servers. It might even be 1 and 16 now, if I'm honest, or 2 and 16 is what I've got, but I think it might have changed to 1 and 16. And these run your specialized operating system that's purposely defined for hyperconverged infrastructures. You can use Azure Stack HCI to virtualize classic enterprise apps such as Exchange, SharePoint, and SQL Server. You can also use it to host VMs running a wide range of Windows Server roles, file servers, DNS, DHCP, IS, that sort of stuff. Finally, you can additionally use Azure Stack HCI. It can provide built-in support for DR, as I mentioned right at the start, virtualized workloads running through stretch clustering. That's something you have to obviously configure. It's not built in like it is with Azure Stack Hub. So this shows some of the use cases I mentioned: branch office and edge virtualization, VDI, where AVD comes in, high performance SQL Server, trusted enterprise virtualization, and tightly integrated Kubernetes as well. I want to talk about some of these use cases in a bit more detail. So for a branch office and edge sort of use case, just like it's is reasonably priced, but highly compute and storage and networking resources for sort of business critical applications and edge workloads that integrate with sort of your containerization and use your IoT edge technologies. From a VDI perspective, Azure Stack HCI clusters are well suited for large scale virtualization desktop deployments. So not just server, but now even end user sort of device stuff with AVD. with the sort of remote desktop services element that it has, or the equivalent third-party offerings, like we said, AVD, Azure Stack HCI can provide, benefits in this use case, which will allow you to do centralized storage and enhance security as well, and that simplifies protecting your user data. There's that SQL Server use case as well. So this provides a layer of resiliency for highly available, mission-critical, always-on availability groups-based deployments of SQL. You can use the Microsoft Certified on Windows Server 2019 based HCI running SQL Server workloads, and these offer extra benefits associated with sort of single vendor approach, including simplified support and performance optimizations. Then we have that trusted enterprise virtualization use case. So Azure Stack HCI can satisfy the requirements of trusted enterprise virtualization through its built-in support for virtualization-based security, or VBS. And VBS relies on Hyper-V to implement the mechanisms referred to as virtual secure mode, which forms sort of dedicated and isolated memory region within its guest VMs. And finally, AKS on Azure Stack HCI. So you sort of clustering and your containerization, sorry. So you can leverage Azure Stack HCI to host container-based deployments, increasing workload density and resource group usage efficiency. Azure Kubernetes Services, or AKS, on Azure Stack HCI, it's Kubernetes-based orchestration that automates running containerized applications on clusters that Azure Stack HCI can manage. So again, it's that same feature, same AKS within Azure, just bringing it onto your data center, basically, in your private on-premises location. So we'll talk a little bit about planning for Azure Stack HCI. So after you verify that Azure Stack HCI is actually suitable for hosting your workloads, you need to consider your infrastructure requirements, including the compute, storage, and your networking components. General planning considerations for your Azure Stack HCI implementation are going to include the number of physical servers per cluster. So this number can be, as I mentioned, I'm pretty sure it's moved to 1. It used to be 2 and 16, but now it's 1 and 16 physical servers. The number of fault domains per cluster. So by default, each node in a storage space's direct cluster is 1 fault domain. The number and type of processors per server as well. So the first of these values determines the core count, and the latter dictates their speed. Type of the amount and type of memory per server, including whether to use persistent memory. Disk performance, including corresponding tiering and sort of caching configuration. And the number and type of capability of your networking adapters as well. The Azure subscription in which you kind of register your Azure Stack HCI deployment as well, because they're going to be charges for Azure Stack HCI clustering depending on the sort of Azure subscription type. Let's talk a little about planning for storage. So in the simplest terms, planning for Azure Stack HCI host storage involves identifying optimal balance between resiliency, capacity, and performance of your storage spaces direct. However, there's a challenge. Maximizing one of these characteristics typically has a negative impact on at least one or the other two. An example of that is if you increase resiliency, this is going to reduce the usability capacity. So storage spaces direct, hard drives, or your HDDs, and your SSDs. So you see storage spaces direct supports hard disk drives, HDDs, solid state disks, and non-volatile memory express as well. And the choice of drive typically directly affects the storage performance due to the difference in performance characteristics of each type of sort of cache mechanism. In general, storage spaces direct assigns drives to 1 or 2 categories based on the drive type, capacity, or cache. Capacity drives provide raw storage for your cluster and typically slower and more capacious than cache drives. And your cache drives are used to accelerate reads and writes to slower capacity drives. In clusters with multiple drive types, storage space direct automatically assigns all the fastest drive types to cache and uses the remaining drives for capacity. And you can manually cache in scenarios where the default configuration doesn't sort of yield optimal performance. We then need to think about drive symmetry. So storage spaces direct works in the optimal manner when every server has the exact same number of type and drives. In general, you should configure your storage space direct cluster in such a way that all servers have the same drive type. Same number of drives per type as well, and same model and firmware version and the same type. All the drives are the same type and same size. Also need to plan for clustering and pool quorum. So in fail-over clustering, the term quorum is the number of clustering components that must be available for that cluster and to remain online. These components can include the clustering nodes and optionally a witness. The term witness specifies dedicated exclusivity to establishing and maintaining quorum. So with storage spaces direct, there are two distinct quorum mechanisms. The first one's cluster quorum, which operates at the cluster level and is based on votes from nodes and witnesses. The other is pool quorum, which operates on the storage pool level, and this is based on votes from nodes and a witness. Finally, when we're talking about planning for host storage, just to discuss store volumes quickly. With storage spaces direct, volumes allow you to group drives within that storage pool in order to yield the optimal combination of fault tolerance, scalability, and performance requirements. You need to consider the number of volumes per cluster, the file system, volume size, reserve capacity, and resiliency type. You're talking about volumes or thinking about volumes. So I just want to touch on planning for networking, for host networking. In the simplest terms, planning for host networking in Azure Stack HCI involves identifying the adapter and physical switch configuration you're going to use. Additional considerations for stretch clusters include intersite network port requirements and latency as well. From a physical network consideration perspective, at minimum, customers or consumers need to ensure that they're using compliant Azure Stack HCI switch, and they know the IP subnets and VLANs for management, storage, and compute traffic. Other network requirements such as data center bridging might also be necessary to integrate into your network requirements for your solution. You think about network ATC. So this is a new service that helps deploy and maintain the host network configuration and is only available on Azure Stack HCI. Network ATC provides multiple benefits, including simplifying host networking deployment across the entire cluster, implements the latest Microsoft validated best practices, keeps all host networking configurations synchronized within the cluster. It remediates administrative misconfigurations to prevent configuration drift, and also streamlines cluster expansion, helping to ensure new servers are deployed exactly the same as others. Then got RDMA. So this is the key networking technology that provides high throughput, low latency communication, and it offloads network traffic from the CPUs, freeing up CPU time for running workloads. Azure Stack HCI configurations can use one of the two common RDMA technologies. First one, which is the recommended one, is the Internet Wide Area RDMA protocol over TCP/IP, with TCP providing flow control and congestion management. You then got RDMA over Converged Ethernet over UDP/IP with data center bridging. Finally, you need to really plan for your software-defined networking. So Azure Stack HCI includes SDN, and it provides network services for existing VLAN-based infrastructures. SDN scenarios for sort of traditional VLAN networks include microsegmentation and QoS, as well as software load balancing or SLB. SDN scenarios for virtualized networks include network virtualization, microsegmentation, QoS, SLB, virtual appliances, and connectivity to external networks as well. Over time, okay, good. Coming towards the end anyway. So let's talk about deploying Azure Stack HCI. So to implement Azure Stack HCI, you should set up Azure Stack HCI hardware. So after you receive an Azure Stack HCI integrated system purchased from Azure Stack HCI catalog through a Microsoft hardware partner, you need to set it up in your data center. So the system should have an Azure Stack HCI OS pre-installed. You also need to configure network connectivity from your internal network to the cluster. You need to create that cluster, so assign the computer names that match your custom naming conventions to Azure Stack HCI operating system instances that are running on Azure Stack HCI nodes, and then you join them to your Active Directory domain services domain. While this is typically your existing domain, you can deploy a self-contained ADDS environment using Azure Stack HCI VMs that are dedicated to Azure Stack HCI environment. When I deployed this in my demo tenant, which I'm going to show the deployment mechanism in my demo, that's exactly what I did. It created its own domain. Finally, you create a failover cluster using Windows Admin Center or PowerShell. And you need to ensure that the computer on which you run Windows Admin Center is joined to the same AD domain in which you created the cluster or a trusted domain. So let's talk about validating Azure Stack HCI. So before deploying production workloads into Azure Stack HCI cluster, you should confirm that its intended configuration is valid and meets intended performance objectives. So these can include validation of cluster configuration by using clustering validation tools, validation of cluster performance by using synthetic workloads. And you can run sort of cluster validation by using validation cluster option Windows Admin Center, or validation of configuration wizard in failover cluster manager as well. You need to validate your network operational state as well, and you can use something called test-netstack for that. So this is a PowerShell testing tool. You can get that from GitHub. And it performs ICMP, TCP, and RDMA traffic testing of networks that can help identify potential network fabric and host misconfiguration or operational instability. You can validate the performance by using sort of synthetic workloads. So most comprehensive performance validation approach relies on generic synthetic workloads that simulate the projected usage patterns, capturing relevant performance characteristics and analyzing that captured data. Let's talk about some of the key benefits of Azure Stack HCI. So with Azure Stack HCI clusters, Azure Arc Agent is included as part of the cluster node's operating system, so you don't need to install it. You activate it by registering the Azure Stack HCI cluster with Azure Arc, which automatically enables Azure base monitoring, support, and billing. Azure Arc enables you to leverage Azure Resource Manager functionality to manage and maintain Azure Stack HCI clusters, and that includes classify all organizational resources by using Azure management groups, subscriptions and resource groups and tags, devise single comprehensive inventory of organizational assets across your multi sort of clouds on premises, including support and searching indexes by using Azure Resource Graph, and then providing a consolidated display of Azure and Azure Arc enabled resources by using the Azure portal, Azure CLI, PowerShell. And again, you can integrate it with Azure Monitor, Azure Backup, and Azure Site Recovery. It integrates with all those key Azure services. Some Azure hybrid services as well. So how does Azure Stack HCI benefit from integration with Azure hybrid services? So it integrates with, as I mentioned, several Azure services, as I think I've mentioned, Monitor, Backup, Azure Site Recovery as well. It leverages these services for critical functionality. To implement this integration, you need to install one or more agents onto on-premises physical or virtual servers. Azure Monitor, Azure Update Management, and Microsoft Defender for Cloud require installation of Log Analytics Agent. The Log Analytics Agent manages a collection of Windows event logs, Windows performance counters, file-based logs, and you explicitly specify the metrics and logs associated with Azure Monitor or Azure Automation Monitoring. Azure Monitor services, so you can integrate with Azure Monitor, as I mentioned. It's core components of Microsoft's strategy to extend comprehensive cloud-based monitoring functionality beyond Azure to on-premises data centers. And it's got three main capabilities, really: metric-based monitoring, querying and analyzing logs, and also alerting and remediation. Let's just talk a little bit about integrating Azure Stack with Azure Arc. So Azure Arc is an example of a solution which allows managing disparate environments at scale, enhancing security across an entire organization, so it can't be compromised, enabling developer agility and innovation can be very critical for businesses to succeed and thrive. Microsoft Azure provides tools and solutions that can help customers like clients to innovate that hybrid environment. And that's kind of what Azure Arc helps you do. It consists of a set of technologies that you can use to simplify administration of complex distributed hybrid environments. Again, it's a diagram, sort of Microsoft Learn diagram, which kind of shows that integration of Azure Arc with multi-cloud. So not just Microsoft, but AWS, GCP, also edge technologies, and also your on-premises as well. It allows you to manage all those in one single pane of glass. And that's just again, that integration with those Azure resource, Azure management. So you can use Azure policies, CLI as well to manage all those. Some of the key benefits. So a number of Azure Arc benefits are independent of resource type because they reflect the capabilities of Azure Resource Manager. Those benefits include the ability to organize all resources by using Azure Management Groups, subscriptions and resource groups and tags. Single comprehensive inventory of your organizational assets across multiple clouds and on-premises. Delegation of permissions on the management plane by using RBAC. Consolidated view of Azure and Azure Arc enabled resources via the Azure portal, CLI, and PowerShell. And finally, integration with Azure Monitor, so you can use it to help monitor and manage those server resources we've mentioned before. I'll talk a little bit about what the role Azure Policy has with Arc-enabled Azure Stack HCI VMs. So Azure Policy is that service that can help organizations to manage and evaluate the internal and regulatory compliance of your Arc-enabled servers. Uses declarative rules based on properties of sort of target resource types, including Windows and Linux OS. These rules form policy definitions, which administrators can apply through sort of policy assignment to resource groups, subscriptions, or management groups. And then simplifying management of your policy definitions, it's possible to combine multiple policies into initiatives, and then these can create a few initiative assignments in lieu of multiple policy assignments. So how do we integrate Azure Stack HCI with Azure Arc? Azure Stack HCI is delivered as an Azure service. You need to register with the Azure subscription within 30 days of its installation. The registration process automatically triggers creation of Azure Stack HCI as your resource manager resource, and this represents an Azure Stack HCI cluster, effectively onboarding it into your Azure management plane. Periodically, it synchronizes with Azure Stack HCI, and then it gives you that reflects within the Azure portal, and you can see how your on-premises cluster. Registering an Azure Stack HCI cluster with Azure Arc is required from the support and billing perspective as well. And it's also likely to serve in the future as the basis for provisioning additional Azure Arc resources, including the process of creating Azure Arc VMs directly from the Azure portal. So how can we leverage Azure Arc to centrally monitor Azure Stack HCI? With Azure Arc, the Azure portal can provide centralized dashboard for status monitoring and launching pad for management of all your Azure Stack HCI clusters, along with all your Azure and Azure Arc enabled resources. Gives you more in-depth monitoring and alerting, log collection, analytics. They're all available through Azure Monitor, as we mentioned. Simplest way to onboard the cluster to Azure Monitor is by using automated workflows in Windows Admin Center, which first provides a log analytics workspace in that target Azure subscription and then configures that health service, and that installs on your cluster node. Once that process is completed, cluster nodes will start forwarding telemetry to Azure Monitor. And the cloud-based monitoring might potentially eliminate the need for an on-premises monitoring system as well. So again, saves you a little bit of money and a bit more, saves you that sort of hardware footprint as well. So the final topic, promise this is the final few slides now. So let's talk about integrating AVD with Azure Stack HCI. So some of the benefits of AVD on Azure Stack HCI is to improve performance of AVD users in areas with poor connectivity to the Azure public cloud by giving them session hosts closer to their location. It can meet data locality as well, these data sovereignty sort of requirements by keeping app and user data on premises. Improves access to legacy on-premises apps as well and data sources by keeping desktop and apps in that same location. Finally, it can reduce the cost and improve user experience with Windows 10 and Windows 11 Enterprise multi-session, which allows concurrent interactive sessions. Again, some more benefits are sort of simplifying that VDI deployment and management compared to sort of traditional on-premises VDI solutions by using the Azure portal. You can achieve really good performance by using RDP short path for low latency user access. And also you can deploy the latest fully patched images quickly and easily using the Azure Marketplace. So essentially it gives you all that cool AVD functionality, but in your data center or your on-premises location. Supported deployment configuration. You need to make sure your Azure Stack HCI cluster is running on a minimum version 23H2, and also that it's registered with Azure. Once your clustering is ready, you can then use the 64-bit operating systems, including Windows 11 Enterprise and Enterprise Multi-Session, Windows 10 Enterprise and Enterprise Multi-Session, as well as Windows Server 22 and 2019. From a licensing perspective, you do need to activate your Windows VMs. So for activating Windows 10 and Windows 11, Enterprise and Multi-Session, and Windows Server 22 Data Center, you can use the sort of like the traditional RDS licensing. There's different activation methods as well. You install the Azure Connected Machine Agent on the virtual machine, so you can communicate with Azure Instance Metadata Services, which is a required endpoint for AVD as well. So make sure you've got the relevant agents installed. From a licensing and pricing perspective, to run AVD with Azure Stack HCI, you need to make sure you're licensed correctly and be aware of that pricing model. So there are 3 components that affect how much it costs for AVD to run Azure Stack HCI. First is a user access right. So these same licenses that grant access to AVD on Azure also apply to AVD on Azure Stack HCI. You've then got an Azure Stack HCI service fee. You've also got an AVD on Azure Stack HCI service fee, and this fee requires you to pay for each active virtual CPU or vCPU for your Azure Virtual Desktop session host running on Azure Stack HCI. So there are 3 different classifications of data for AVD, such as customer input, customer data, diagnostic data, and service generated data. With Azure Stack HCI, you can choose to store user data on premises when you deploy session hosts, virtual machines, and associated services such as file servers. However, there is some customer data, diagnostic data, and service generated data that needs to still stay in Azure. So, like anything, it does have its limitations. There are some features that are not supported, like AVD Insights, session host scaling with Azure Automation, and per user access pricing. Also, each host pool must only contain session hosts on Azure or on Azure Stack HCI. You can't mix session hosts on Azure and Azure Stack HCI in the same host pool. Azure Stack HCI supports many different types of hardware on premises network capabilities, so performance and user density might vary compared to session nodes running in Azure. Finally, you can join session hosts on Azure Stack HCI to an Active Directory domain service domain only, so you can't do Azure AD join. Okay, that is the end of me yabbering on. I'm now going to share my screen and do a quick demo. I was expecting to look at the chat and be no one left in the on the meetup. I would bored everybody. So I want to quickly just show what I use to do my deployment within my virtual environment. So I used Azure Arc Jumpstart. So I'll put the URL in the chat because I recommend having a look at this if you can. And it's got various scenarios you can do, lots of Agora, Arcbox, HCI box, which is what I used, and you can essentially deploy these in your virtual environment, your Azure environment, and the one I specifically, as I said, was your Stack HCI box. So I'll quickly share my Azure tenant screen, find it. Okay, so here I am. This is my demo portal, and I'm going to open up. So you can either have a management machine and use PowerShell to connect into your environment, or you can just use the Cloud Shell. I just found it easy to use a Cloud Shell. So all these steps are available from the Azure Arc Jumpstart website. By the way, you can find a guide on how to do this. So what I'm doing here is I'm going through the process of provisioning Azure Stack HCI within my Azure tenant as a virtual sandbox. Okay, so the first thing is we need to clone the Azure Arc Jumpstart repository because that's where all the information is that we need. So we do git clone and then the repository. That clones it. And essentially that's going to download that folder into my local repository, and I'll just let that finish. This is a live demo, by the way, so I don't actually think I've done a live demo on a user group before. So okay, so just to prove that that's downloaded, there we see the Azure underscore arc. And if I try to download it again, you would get an error. So just to show that, prove I've not downloaded it, it tells you it's already exists, so you can't download it twice. The next thing we want to do is so this is called the AZD init command. Actually, no, sorry. First, we need to go to that. We need to go to that. We need to go to that location that we've downloaded. So yeah, we'll go there. I can't remember what the exact path is, and it's the Azure Arc. It's the Azure Jumpstart HCI box. So we'll go cd Azure underscore Jumpstart underscore HCI box. Ooh. Right, now we want to do the command, which is AZD init. And what this is going to do is going to start the process of us deploying the Azure Stack HCI in our tenant. Oops, wrong one. And there's a number of things it's going to ask us. So enter a new environment name. So we just call this HCI demo. So you got to give it a name first of all. So that's created the environment. So we've initialized it, and now we need to actually bring it up. So we do the AZD up command. And what this is going to do is deploy the environment. And there's going to be a couple of prompts that are going to ask us for some credentials and you know, setting up a little bits, but we'll go through that in a second. Okay, for time. So it does take about 20-30 minutes to deploy. So I'm not going to go through the whole, you know, I'm not going to show you the whole, you know, everything going down, but we'll get to the point where it does take, you know, point we can't enter any more information. So the first thing is to choose the relevant subscription. So I've got my IMIT Geek one, so I'm just going to press enter on that. Then you get to choose a location. So you've only got 3 available locations: Australia East, West Europe, or East US. So I'm just going to do West Europe just for the argument's sake. I'm going to delete this straight after anyway. So we need to put in a value for our Windows admin password, and this password is going to be the same across everything. So when you log into the local Active Directory domain that it sets up, this will be the same password. It'll be the same for your any local admin of the servers, the virtual servers it set up. Every password, this will be what you use. Okay, so I'm just going to use 2024. Oh, use something else actually. Okay. So this is when it starts going through that process now of registering the Azure provider, which again, as we mentioned in my presentation, you need to make sure you're doing.
Just while this is deploying, Shabaz, if people wanted to try this in their own environment, what's the cost of running this?
I would be very careful. It can be very expensive. So I'm very lucky with, as part of my Microsoft MVP, I get some help from Microsoft. But yeah, it's very, very expensive. Essentially, it deploys loads of infrastructure. So it deploys quite big virtual machines, but also a lot of storage as well. And the sort of SSD storage also can be very expensive. We're talking thousands per month, not hundreds. So okay, I'm deploying this right now. As soon as it's deployed, I'm going to delete it because I'm just going to do the delete command is AZD space down, and it deletes it. So it can be very, very expensive. I even switched off my virtual machine. I stopped my virtual machines, and it still just ate everything up because it uses Bastion, and there's loads of expensive services it does create as well as part of it. So just be very careful. So okay, and it's asked me for a username. So again, this is going to be my admin username for the whole. Whenever I log into anything like a VM or a Hyper-V, Hyper-V host, it's always going to be that username and the password we put before, which will start out. You can leave it on the default one if you want. So configure Azure Bastion. Again, I did do this. You don't have to, but I'm going to do no in this case. So if I forget to delete all this, it's going to cost me a bomb. So you can, I'd probably recommend doing it because then it allows you to use Bastion to connect to your virtual machines and stuff like that. Otherwise, you're going to have to open up ports. It can be a bit messy. Let's go no for now. So I'm just going to leave it on the default. Again, this is going to open up 3389 on your Windows VMs that it deploys. So this is just checking for existing service principal and it's just doing that configuration. And now it's going through, it's using Bicep to do that deployment now. So this is now it's going to take about 20 to 30 minutes. Yeah, it's ridiculously expensive, Brad, 100% right. So I won't bore you by showing you all of that because I'm sure some of you want to go and have your tea like I do. So that is the end of my session. Thank you very much. Are there any questions in the chat?
There's no questions, but someone's putting a rough estimate saying it's going to cost round about just over $2,500 a month to run it.
There was a question from, sorry, Shabaz. There was a question from Alan in terms of AVD. How do the costs compare between Azure and Azure Stack?
From an AVD perspective,
Yeah.
From a consumption perspective, it'll be because it's a bit different. It's a licensing that you'll be paying for, so the licensing is a bit different because I said you've got those different service fees. But if you think about AVD in Azure, you're paying for the consumption, aren't you? Using the storage and the virtual machine stuff. You're not doing that with Azure Stack HCI because it's using local compute that you've got on premises. You've already kind of paid for it. Does that make sense? Oh, but again, it does use the same subscription model, but Azure Stack HCI, so the same pay monthly, but you've already got that set because you're paying for the Azure Stack HCI storage and networking. That you're not paying for the AVD consumption, if that makes sense, as you do in Azure. Does that make sense, Alan?
Alan, what do you mean by your last
yeah,
question?
sort of. Yeah.
Okay, I know what it means. It's a bit asking, can you, so no, because the hardware needs to be validated, Alan?
I thought there was a test version at one point you could fire up with some restrictions, or have they got rid of that one now?
They might have got rid of it.
There was back in the day, you could run it, I think it's like 90 days, but you needed like 256 gigs of RAM and like 32 cores or something.
Yeah, there was a version that I think it slimmed down to 128 gig of RAM or something.
Yeah, they used to be. I don't know whether there still is, but yeah, if you've got a PC with that sort of like specs, pretty cool. And then yeah, you would be able to.
I've only found, but yeah, there was back when it first kind of came out, there was, but I think now they've gone for this like virtualization sandbox that I've kind of deployed.
I remember somebody running it on what was that ThinkPad workstation laptop that you could max the memory out to somewhere between 128 and 250. Somebody fired it up on one of those. I don't remember who it was. Was it WS540 or something?
Did the laptop explode?
No, it was fine.
So yeah, like Sam said, I do remember there being something a while ago, but
it's just obviously one of the problems is when you talk, forget about not forget about it, but obviously your thing is AVD to an extent. You're obviously you talking about using it on Azure Stack, which obviously can do other stuff like AKS and that. But if the problem I always had with it is if you can't get your hands on one to use and play with, it's it sounds amazing and it'd be nice to be able to gain some experience with it. And and obviously I know that you're firing that thing up in Azure. which is fine because it can be done, but it's just obviously, oh, well, I want to have an experiment with it, you know, and the bill's going to be horrific, you know, while you're doing some learning and stuff.
And I think it's like anything, Alan. I think that the more uptake it gets in businesses, and I know there is a lot of, again, now that AVD is available on it, the amount of conversations I'm having about Azure Stack HCI is crazy. I was talking to Lisa Clark, who works at Dell, the other day, and she was saying the same thing, that the amount of conversations, now AVD is available on it, and you can put user workloads, not just server workloads on it. I can see it being having a lot more uptake. Yeah, it's ridiculously expensive. Like I said, I've got my YouTube series around it. I'm just in the middle of, and I had to really do that record it as quick as possible, and my demos as quick as possible, just because like every day I'd check and it'd be another 300 quid off my thing, and I'd be like, oh God, what's happening? Yeah, you're right, Alan. It's one of those things where only a select number of people will probably get to have a play with it. It's not like, you know, you can, like you said, with AKS, you can just go deploy it in your Azure tenant, you know, your own demo tenant, have a good play with it. It's not going to cost you that much. But this is unfortunately.
So that being said, I've had a quick Google, and apparently from the Azure portal, you can download an Azure Stack HCI ISO, which is 5 and a bit gig. It's 3.5 gig, it says.
What's the minimum spec to run that thing though, Simon?
That's the problem.
that's what I'm just looking. It doesn't. So I've put the link in chat, and it says that you can download it, and it includes a 60-day free trial, but doesn't give me any specs.
We'll stick it on your PC tonight, and Simon, and get back to us how it works.
Yeah,
you've got enough hardware there. You've got a rack of servers somewhere.
Yeah, that's down in Birmingham, not up here. But yeah.
What are your second backup data center?
That's the one.
We'll see a news article in garage fire in Birmingham after somebody tried to install Azure Stack HCI on a little laptop.
You know the Dell hybrid workstation stuff. They'll spot that kind of hardware. So it's just a single. It's a hybrid between a PC and a workstation, but they spot half a terabyte of RAM, and they take 8 SSDs.
I've got my old Alienware laptop that takes 4 SSDs. It's got 4 in it at the minute. It's just the memory won't go anywhere near that. That's the only problem.
Just looking at Cash's question around the safety of differ between desktop, mobile, and application. Sorry, Cash. What do you mean? Just come off mute if you want, Cash.
Yes, sorry. I mean, I was just saying because I missed about 10 minutes of your speech.
No problem.
Presentation. Like comparing to this HCI stack and the existing technologies such as virtualization and all that. So HCI is like a one band solution for everything.
Yeah, it's hyper converged basically. So the only thing I can compare it to is something like, because essentially you've got your storage, your networking, and your compute all in one.
V-blocks or whatever it was called.
Yeah.
It's instead of so in old school virtualization, you could do old school, but you could buy so we used to buy Dell blades with compute and memory, but no storage, and the storage layer would effectively be our SAN, which gives you quite a bit of flexibility. The problem is the SAN part of it cost an absolute arm and a leg, and that had no mechanical disks in it at all. That was all SSD, super fast cache, and whatever. It was off the Richter scale I/O. But a conventional like VMware solution, you'd buy a server with some compute, some memory, some storage, and you'd add a number of those servers together to produce your clusters. The idea behind HCI stemmed from that. Well, what if we could sell a block that came in one concise chunk, and then you can just add as many of those blocks together as you want? Now, it limits some of the flexibility, but for your average organization that's not got a lot of expertise in sound storage and things, you could build up a cluster and you just keep adding blocks of stuff. And they were tended to be a bit more rack friendly because they came in a certain 2 or 4 U, and you just keep adding them, and as you want more stuff, and it sort of linearly expands.
And I think with the Azure Stack HCI as well, you can manage that side of it through like PowerShell and stuff like that. So it uses those same Does that answer your question, Cash? It's a hyper-converged, basically. Like Alan said, it's an all-in-one storage, networking, and compute in one node, one server, basically.
Got it. Thanks.
It's basically a way of getting yourself a pool of resources that you can put virtual stuff on, whether that's Hyper-V, VMware, Azure Stack, or whatever your preferred hypervisor might be.
There was a
and then on top of that, you layer whatever it is you want to run on top of that. It's there
was a big craze around it about 10 years ago. There was Cisco did FlexPod. And there's a couple of other vendors that kind of went into the hyper-converged area.
NetApp was big on it.
Yeah, well, some of them.
NetApp was part of your FlexPod. The FlexPod was Cisco UCSs, Cisco switches, and NetApp storage. Yeah.
NetApp also did the whole compute HCI thing, so you could buy the whole stack from NetApp. I don't know who did the compute for them, but it was NetApp, branded.
There was better ones than that more. And I can't remember, honestly. I'm sure I'm going senile. I can't remember the names of the ones we looked at because we had Dell Blades. And we looked at some of the hyper-converged. Obviously, Dell had some options in that space. But
someone began with H. I can't remember what someone began with H.
VMware had their own version called vBlock for a while, but then they binned that off and left it to third parties to come up with hardware which they would approve and ratify for
Nutanix.
That's it. Well done, Shabaz. That's the one I was trying to think of.
Yeah, Nutanix. They were the big player. They were definitely the big player.
And they also had different versions of hypervisor you could have with it. Out of the box, you could have like VMware or Azure Stack, but they also had 2 or 3 independent hypervisors that didn't necessarily have some of the costs, particularly that VMware had for running their stuff on them. But would run the same sorts of workloads, but just it saved you a chunk of change in the software layer.
Yeah. So to go back to your question, on it says here, and I put a picture and a link in chat. I found the required specs for it. It says you need a node with a minimum of 32 gigs of memory.
Well, that's not very much.
And then the prereqs are you need like a 200 gig boot disk, 2 data disks, TPM 2.0.
That's the box I've got.
So it's currently running in a VM, although I didn't see that I needed 2 data disks, so it might just crash, but it's currently installing Azure Stack HCI. If anyone is curious.
I've got a server somewhere that needs unmothballing, and I need to dig the side off to see. Certainly got enough space disk-wise, and I can't remember how much RAM it would take.
Is there any more
I
questions?
did suggest it at my previous place, Shabaz, in terms of we could switch out VMware for Azure Stack, but wasn't exactly well received as a prospect.
Honestly, I think now AVD is coming to the picture. A lot of like I said, the amount of people that have reached out to me. It says I've done my series as well. People have reached out to me. Oh, we're looking at this now. AVD is available. People have been waiting for AVD to become available.
I'm surprised because to me, the biggest use case for people would be if you've started doing Azure Cloudy stuff, but you have some kind of on-premise virtual footprint, which is not exactly. I'm not trying to big up VMware, but obviously it's quite common to have that. If you switched and migrated those VMs onto Azure Stack, it gives you the flexibility, to my mind, of moving stuff from on-prem to the cloud and vice versa, depending on what your business requirements are.
Well, I've got a question for you, Shabaz. You know the thing you mentioned right at the beginning. Can this be a fully offline version? I mean, because it needs to talk to something to get its updates. Can you proxy the updates?
No, Azure Stack Hub it can have in disconnected mode, not Azure Stack HCI.
So basically, Mo,
disconnected.
Mo, on your cruise ship that you've got, you're going to have to use Azure Stack Hub.
Yeah. So for environments like, again, for we're talking government, like secret stuff like that.
Yeah.
where it has to be siloed and air gapped from any other sort of network. Can't have any outside connectivity. Azure Stack Hub would be a good conversation starter. I think would be a good thing to bring to the table because it has that disconnected mode.
Obviously, my joke failed, Shabaz there. But as I understand it, the common use scenario for the offline version is on the massive, the 3,000, 4,000 people cruise ships, and the other big user is oil rigs.
Yeah.
See, in the secure environment,
I
was going to say in the secure environment, Shabaz, you don't necessarily need it to be offline. It doesn't need to have a direct connection to the internet. So if the updates can be proxied through a secure connection somewhere else, then because you want to keep it up to date, you want to install the new features. If that means talking out to the internet, it just means it can't talk out the internet directly. It has to go through some secure connection somewhere else.
I don't know the ins and outs of how it gets updates, but there is a disconnected mode you would do with Azure Stack Hub only.
I'll look into it. And can you run AVD on Azure Stack Hub?
No,
you can't. Can you? That's the problem.
No.
Yeah.
So there's one I won't name them. There's one client that we've both worked with that I know for a fact are now doing Azure Stack HCI because AVD is available on it. I think I mentioned this to you.
I know another one that wants to run it, or would be potentially interested in running it, which meets the government level stuff that we're talking about here.
I mentioned to you last week when we went for dinner. I mentioned to you who contacted me. Yeah.
But this one needs to be completely offline. But obviously, you need then a way to keep it up to date.
Well, I wonder if it's somewhere that's got a super secure requirement, they wouldn't even be happy. They want that kind of stuff totally air gapped, and I'm not that super experienced with it, but
sorry, exactly. And so what you do is you would download the updates from a different mechanism, write some proxy somewhere, and then have a mechanism that allows you to take, screen those updates, and then take those updates from where you've downloaded them, and then even if that's a manual process to copy those updates to a secure external drive, walk it across to your air gap environment, update them. You can't have those environments directly, but you need a mechanism to keep the environment up to date. New features, new capabilities.
The deployment's finished. Sorry, the deployment's actually finished. 17 minutes, not bad. So this is what it deploys basically. Loads of disks, which are pretty beefy as well. It's like, premium disks as well.
256 gig.
Yeah, P15. So it's not small disks, and they're keeping enough of them. But then it does like a really beefy VM. So this is your management box, your management server. And if you shut this down, so I found this out the hard way. I was trying to stop it. I stopped it to keep my cost down. But then all my entire HCI thing went down. So this has to be on for that. And this is an E32, so it's got 32 vCPUs and 256 grams. So it's not
cheap.
Nope. Hence,
I bet between that and those nicely expensive disks it's got attached, the costs would be quite eye-watering.
So I've only installed it now. You've got to do a deployment, and that deploys like all your Azure Arc hosts, and it has multiple hosts in it as well. So this is just part one of the deployment. There's actually loads more you need to do, but I am literally going to do the
get it all
AZD down. Bye-bye.
Nice.
That 3 minutes alone has cost me $4,000. So I'm just get rid of it.
You'd think somebody would come up with a pared down version of it that
they might do. They might do at some point, but right now, because it's.
I know they don't want people to go, oh, well, I'll have a go with this jump start, and the thing that pops out the other end isn't up to the task of doing whatever they want to chuck at it.